Have you ever pondered over the possibility of editing the genetic code of life itself? The rise of CRISPR technology has turned this thought into a reality. In the late 1980s, an intriguing pattern of DNA sequences was discovered in a common bacterium by a curious scientist named Francisco Mojica. These sequences, known as clustered regularly interspaced short palindromic repeats, or CRISPR for short, were arranged in an unusual way. They were repetitive and regularly interspaced, something uncommon in the world of genetics. At first, the function of these sequences was a mystery. They seemed to be a part of a larger system, but their purpose was unclear. It was only after years of research and investigation that Mojica and his team came to a startling realization. CRISPR was a part of a bacterial immune system, a sophisticated defense mechanism that bacteria use to fend off viral invaders. You see, when a bacterium encounters a virus, it cuts up the virus's DNA and stores a piece of it in its own DNA within these CRISPR sequences. If the same virus tries to attack again, the bacterium recognizes it and uses the stored DNA to guide a protein, known as CAs, to destroy the virus. In essence, bacteria were using CRISPR as a kind of wanted poster, helping them to identify and eliminate threats. But the real game changer was yet to come. Scientists realized that if bacteria could use CRISPR to edit their own DNA, perhaps we could harness this system to edit the DNA of other organisms, including humans. This realization opened up a world of possibilities for genetic engineering, from curing genetic diseases to enhancing crop yields, and even potentially creating designer babies. Thus began a new chapter in the realm of genetic engineering with the discovery of CRISPR. Imagine wielding a pair of molecular scissors, precise enough to cut and paste DNA at will. This is not a far-fetched science fiction concept, but a reality in the world of genetic engineering thanks to the revolutionary technology known as CRISPR. In the year 2012, a groundbreaking discovery was made by two brilliant scientists, Jennifer Doudna and Emmanuel Charpentier. They demonstrated that CRISPR, which stands for clustered regularly interspaced short palindromic repeats, could be programmed to cut any DNA sequence a scientist wishes. This was a game changer. It meant that the complex code of life written in our DNA could now be edited, much like how one edits a document with a word processor. Before CRISPR, making precise changes to the DNA was a laborious and imprecise task. But with the arrival of this technology, the world of genetic engineering was revolutionized. It was akin to shifting from a manual typewriter to a computer for editing a document. The precision and ease of use of CRISPR opened up a whole new realm of possibilities in genetic engineering. CRISPR is essentially a system that bacteria use to defend themselves against viruses. They capture snippets of DNA from invading viruses and use them to create DNA segments known as CRISPR arrays. These arrays help the bacteria recognize and cut up the DNA of similar viruses during future attacks. Doudna and Charpentier's pioneering work showed that this bacterial immune system could be repurposed as a powerful tool for editing the DNA of any organism, including humans. The potential applications of CRISPR are vast. It can be used to correct genetic defects, treat diseases, improve crop yield, and even potentially bring extinct species back to life. Its potential is only limited by our imagination and our ethical boundaries. CRISPR, once an obscure bacterial immune system, was now a powerful tool in the hands of genetic engineers. How about curing genetic diseases by rewriting the faulty genes? A question that has stirred the world of medicine like never before, thanks to the revolutionary CRISPR technology. It's like having a molecular scalpel that can slice and edit the DNA at precise locations, enabling scientists to correct genetic defects with astonishing accuracy. This revolution began in the confines of a laboratory, where scientists experimented with CRISPR to rewrite the genetic code in cells. The early experiments involved simple organisms, like bacteria and yeast, but soon the technology was being used to edit the DNA of more complex creatures. In animals, CRISPR has been a game changer. It has been used to produce disease-resistant livestock, create mosquitoes that can't transmit malaria, and even reverse genetic mutations in mice that mimic human diseases. The results were exciting, and it wasn't long before scientists wondered if the technology could be used to treat diseases in humans. The first human trials of CRISPR were groundbreaking. In one trial, scientists used CRISPR to edit the genes of a patient's own immune cells, enabling them to fight cancer more effectively. In another, CRISPR was delivered directly into a patient's body to treat a rare genetic disorder. These trials demonstrated that CRISPR could be used safely and effectively in humans, opening up a world of possibilities for treating genetic diseases. But it wasn't all smooth sailing. The technology is still in its infancy, and there are significant challenges to overcome. The precision of CRISPR, while remarkable, isn't perfect. Off-target effects, where CRISPR cuts at the wrong place in the DNA, can lead to unintended consequences. And there are ethical considerations too, especially when it comes to editing the human germline, the DNA that is passed on to future generations. CRISPR's potential in medicine was starting to be recognized, but not without challenges. Despite these hurdles, the revolution has begun, and the world of medicine may never be the same again. What if a single approval could change the future of medicine? That's exactly what happened when the first CRISPR-based medicine received its approval in the United States. This wasn't just an endorsement of a new drug. It was a nod to a revolutionary technology that has the potential to rewrite the script of human health. The approval of this CRISPR medicine represents a significant milestone in the field of medicine. It's the first time that gene editing technology has been officially recognized as a viable therapeutic option. This opens the door for a new era of treatment possibilities where we could potentially fix genetic issues at their source. But as with any breakthrough, CRISPR isn't without its potential side effects. One of the most prominent concerns is the possibility of off-target effects. This means that while the CRISPR system is editing a specific gene, it could inadvertently alter other genes as well, leading to unintended consequences. Another concern is the ethical implications of this technology. CRISPR has the power to alter the genetic code, which means we could potentially change the traits of future generations. This raises questions about who gets to decide which traits are desirable and which are not. Moreover, there's the risk of exacerbating social inequalities. Imagine a world where only the wealthy can afford to edit their genes or those of their children, creating a class of genetically enhanced individuals. These ethical challenges need to be addressed as we navigate the brave new world of CRISPR technology. Despite these potential side effects and ethical concerns, the approval of the first CRISPR medicine is a testament to the immense potential of this technology. It's a step towards a future where we could potentially cure genetic diseases, rather than just manage their symptoms. The first CRISPR medicine approval was indeed a milestone, but the journey of CRISPR is far from over. We're just starting to scratch the surface of what this technology can do, and that's what makes it so exciting. As we continue to explore its potential, we must also keep in mind the ethical considerations and potential side effects. In this way, we can ensure that the power of CRISPR is harnessed responsibly, for the benefit of all. What does the future hold for CRISPR and genetic medicine? This, my friends, is the question that resonates in the minds of scientists, ethicists, and the curious alike as we venture deeper into the realm of genetic engineering. Imagine a world where we could design our offspring, selecting traits like eye color, intelligence, or athleticism. This is not the plot of a science fiction novel, but a potential reality with CRISPR technology. The concept of designer babies could revolutionize reproductive medicine and redefine our understanding of human potential. But the potential of CRISPR stretches far beyond aesthetics and abilities. The true marvel lies in its potential to cure all genetic diseases. From cystic fibrosis to Huntington's disease, the promise of a world without genetic afflictions is on the horizon. However, this vision is not without its challenges. The extension of human lifespan is another fascinating prospect. By manipulating our genes, we could potentially slow down the aging process and extend our time on this beautiful planet. But would this create a divide between those who can afford such advancements and those who cannot? This brings us to the ethical and societal implications of such advancements. The power to alter the human genome raises profound questions. Who gets to decide what traits are desirable? What happens to genetic diversity? And what about the potential for misuse? These are questions we must grapple with as we stride forward. The future of CRISPR technology is a double-edged sword. On one hand, it offers the potential to It holds the promise of unparalleled medical advancements, but also poses significant ethical dilemmas. It's a tool, and like any tool, its impact depends on how we use it. As we stand on the brink of a new era in genetic medicine, the future of CRISPR technology is both fascinating and challenging. The road ahead is uncharted, but one thing is certain: we are witnessing the dawn of a new era in medicine. The possibilities are endless, and the future is now. CRISPR, a journey from an obscure bacterial immune system to a revolutionary tool in genetic medicine. We've traversed the path from its discovery in simple bacteria to its transformation into a powerful tool for genetic engineering. We've seen how it's been harnessed for therapeutic applications, leading to the approval of the very first CRISPR medicine. And we've also taken a sober look at potential side effects. As we gaze into the future, it's evident that our journey with CRISPR is just beginning. As we continue to explore and understand the potential of CRISPR, one thing is clear: we are witnessing a revolution in genetic medicine that could change our lives in ways we can only begin to imagine.